Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. This is the second video on the chapter sets. In the first video, we learned the definition of sets and some terms. We also studied the types of sets. We looked at subsets and supersets, and we looked at some examples of set of numbers. In this video, we are going to learn how to describe a set and the operations on sets. So we begin with the first one, description on sets. Sets can be described by three main ways. The first is by listing the members of the set. So for example, the members of set A are 1, 2, 3, 4, and 5, and the members of set B are 1, 3, 5, 7, 9, and it continues up to infinity. So we can see clearly from here that the members of the set are listed. Now we move on to the second way of describing a set is by giving a word description of the set. So with this example, set D is given by the factors of 20. So what this means is that the members of set D are the factors of 20. So if you want to list the members of set D, it's given by the factors of 20, which are 1, 2, 5, 10, and 20. The factors of a number are the numbers that can divide that particular number without a remainder. So the factors of 20 are numbers that can divide 20 without a remainder, and those numbers are 1, 2, 5, 10, and 20. Another example of a word description is given by set P. Set P is equal to natural numbers less than 10. In the previous video, we learned that natural numbers starts from 1, 2, 3, and continues up to infinity. So natural numbers less than 10 are 1, 2, 3, 4, 5, 6, 7, 8, and 9. So you could see that in each case, when the word description is given, you have to list the members of the set. Then another way of describing a set is by using what you call the set builder notation. Here is an example. Set C is given by S is such that S is greater than 3 and less than or equal to 12. Now I'm going to bring the pen so that I'll be able to explain this to you very well. So we can see clearly that the set C is given by a set of members, and that set of members is represented by S, and they are numbers that are greater than 3 and at the same time less than or equal to 12. So when a set builder notation is given, we can see from this example that there are two parts. The first part, which is S is greater than 3, and the second part, which is S is less than or equal to 12. So I'm changing that color to green so that you see the two parts I'm talking about. So the first part is S is greater than 3, and the second part is S is less than or equal to 12. So we are going to list members that are greater than 3 and at the same time less than or equal to 12, and those numbers are 4, 5, 6, 7, 8, 9, 10, 11, and 12. So you can see that 3 and 12 are the limits. 3 is called the lower limit and 12 is called the upper limit. So the lower limit gives us an indication of where to start, and the upper limit gives us an indication of where to stop. Here we saw that S is greater than 3, not greater than or equal to 3. And since S is greater than 3, then it means that we must start from 4. We included 12 because S is less than or equal to 12, so 12 has to be included. Now let's take another example. The set D is being described by members, and those members are represented by a variable y, and y is such that y is greater than -2 and y is less than 4. So we are looking at numbers greater than -2 and less than 4. And those numbers will be -1, 0, 1, 2, and 3. So you can see from here that y is greater than -2, which means that you are going to start from -1. The next one will be 0, 2, 2, and 3. The lower limit is -2 and the upper limit is 4. Once again, the lower limit shows you where to start and the upper limit shows you where to stop. We did not include -2 and 4 because y is strictly greater than -2 and strictly less than 4. So we did not include them. Another example is this. The set A is being described by members, and those members are represented by S, and S is such that S is greater than or equal to 1 and less than or equal to 6. So you can see from here that the lower limit is 1 and the upper limit is 6. Now S is greater than or equal to, so in this case 1 will be included, and at the same time S is less than or equal to 6, so in this case 6 will also be included. So we start from 1, 2, 3, 4, 5, and 6. Another example is this. B is given by some members, and those members are being described by Y, and Y is greater than 3. So you see from here that we only have the lower limit, we only have the starting point. So we start listing whole numbers greater than 3. So 4, 5, 6, and since an upper limit was not given to us, this set will continue. The members of this set will continue up to infinity. We move on to the next thing, operations on sets. We are going to consider 3 operations on sets. The first one is the intersection, the next one is the union, then the next one is the complement. So we begin with intersection. The intersection of sets A and B is the set of members that belong to both set A and set B. So an example is given. If you have set A with the members 4, 5, 6 and set B with the members 1, 2, 3, 4, and 5, then A intersection B, which is the intersection of A and B, refers to members that are in A and at the same time in B. So you can see that 4 is in A and is in B, 5 is in A and is in B. So A intersection B is given by 4 and 5. We move on to the next one, which is the union. The union of two sets A and B is formed by putting the members of the two sets together. Once again, we take another example. If you have set A with the members 4, 5, and 6 and set B with the members 1, 2, 3, and 4. If you want A union B, which is written as A union B, then you will get it by putting the members of A and B together. So we put the members together. So we take 1, 2, 3, 4, 5, and 6. Now you can see from here that 4 is in A and at the same time in B. But since we are finding the union of A and B, we only write it as 1. Even though it's in 4 and it's in A and at the same time in B, we are going to write it once. So A union B is given by 1, 2, 3, 4, 5, and 6. So you put the members of A and B together to get A union B. We move on to the next one, which is the complement. If A is a subset of the universal set U, then the complement of A is the set of members which belong to the universal set U but does not belong to the set A. Now this is what it means. If you have U here being our universal set with the members 1, 2, 3, 4, and 5, and A here being a subset of the universal set with the members 1, 2, 3. A complement refers to members in the universal sets that are not in set A. So what are these members? You can see that the members in A are 1, 2, 3. So you take those members out of the universal set. The remaining members are what we call A complement. So we take 1 out, we take 2 out, we take 3 out. You see that it will be left with 4 and 5. So 4 and 5 become the complement of A. Members in the universal set that are not in A. We are going to take a lot of examples on this in subsequent videos, so you are going to get this very well. Thank you for watching this video. See you in the next video, where we will take a question based on the previous videos that you've watched. Thank you and bye bye.